Hello guys, today we'll be talking about how to prove quadratic formula, solving quadratic equation using quadratic formula. So as you can see on your screen, the quadratic formula is nothing but x equals to minus b plus or minus square root of b squared minus 4ac divided by 2a. And this formula, at times we call it the giant quadratic formula. This is because there are other methods we can use to solve quadratic equations. Such methods may be completing the square, graphical method, factorization method. But these methods may not work for all quadratic equations, but for the formula method. So if we should know one method of solving any quadratic equation, we should be able to use the formula method. That's why this formula is very important. And some of the questions may ask you to prove this quadratic formula, and that's why we are here today. So after we must have proven this formula, we are going to use this formula to solve the equation 3x squared minus 5x plus 2 equals to 0, and we are going to discover that the results will be nothing but x equals to 1 and x equals to 2 on 3. So deriving the quadratic formula. If you are new to my channel, don't forget to subscribe, hit the notification bell, like and share my videos to many others who may need this. Okay, without wasting much of your time, let's go into the question proper. So for us to solve this equation, we need to know the general form of a quadratic equation, which is given by ax squared plus bx plus c equals to 0. A can be a positive or a negative number, b as well can be a positive or a negative number, c can be a positive or a negative number. So let's assume all the numbers are positive. If any of the number is a negative number, the same process we are going to use here will be unchanged. The only part is that we are going to change the negative number, the positive numbers to a negative number, and every other thing remains constant. So we call a, b and c the coefficients of x squared, the coefficient of x, and the constant term c, that is the y-intercept c. So the a, b and the c are constants, so they are numbers. So before we go on, we need to know what are we proving. We are proving that the x value can be gotten by taking the negative b positive or minus the square root of b squared minus 4ac divided by 2a. That is the quadratic formula, and that is what we are proving. So let's represent the equation again, the general form of a quadratic equation, which is that. So for us to get this formula from this quadratic equation, we need to make the coefficient of x squared be 1. So in this case, the coefficient of x squared is a, the coefficient of x is b, and the constant here, which is the intercept, is c. So we need to make this coefficient of x squared, which is a, to become 1. How do we make to become 1? We divide all through this equation by a. So let's divide ax squared by a, bx by a, c by a, and 0 by a. So we'll divide that by a, divide bx by a, divide c by a, and we divide 0 by a. So in that case, the a here will take care of the a, and we are going to be left with x squared, which makes the coefficient of x to be 1. That's it. So we are going to have x squared plus b on ax plus c on a equals to 0 on a. Anything 0 divided by anything is 0, so it will bring 0 on a back to 0. Now the next thing, let's collect like terms together. What are the like terms? Like terms are terms with x, and then c on a is a constant term. It does not contain x, so let's take it to the other constant term, which is 0. So we'll bring like terms together. In this case, we are going to leave x squared plus b on a x on one side, and we take c on a to the other side. If we take it to the other side, its sign will change from positive, because it's positive c on a here, from positive to negative. So when we do that, we are going to have x squared plus b on ax equals to minus c on a. What do? we now need to make this x squared plus b on ax become a perfect square. What is a perfect square? A perfect square is simply a number when we apply the square root to it, it will give us a whole number without a remainder. For example, 4 is a perfect square because the square root of 4 is 2. 2 remainder 0. So what other number is a perfect square? Find other perfect square numbers like 9. 9 is a perfect square. Square root of 9 is 3. So we need to make this x squared plus b on ax to become a perfect square. But remember, this is an equation, so whatever we do to this side of the equation, to the left hand side of the equation, we must do it to the right hand side of the equation too, so that the nature of that equation should remain unchanged, right? Okay, so if we do that, we are going to have x squared plus b on ax. To do that, we need to take half the coefficient of x. What is the coefficient of x? B on a. So we need to take half of it. Half of b on a is b on 2a, right? So if we take half of that coefficient, b on 2a, which is b on a divided by 2, will give us b on 2a, right? So we are going to have b on 2a, which is half the coefficient of x. Then we square it and add it to the left hand side and the right hand side. So if we do that, we are going to have x squared plus b on ax plus b on 2a, all that squared. So half the coefficient of x, which is b on a, the half of that coefficient is b on 2a. We square it, so it becomes b on 2a, all that squared. We add it to the left hand side of the equation and we add it to the right hand side of the equation so that the equation remain unchanged. So in that case, this left hand side of x squared plus b on ax plus b on 2a, all that squared, is now a perfect square. So if it's a perfect square, then we can summarize it to be the form. In the form, we take these values that are squared here and we put them together. So we are going to have x plus b on 2a, all that squared, is equals to minus c on a. B on 2a squared is, we square b divided by 2 squared is 4 and a squared is a squared. So that is a simplification of b on 2a, all that squared, right? So in that case, this, if you open up this bracket here, you will still have x squared plus b on ax plus b on 2a, all that squared. So nothing has changed. That's why we wanted to make this a perfect square, so that we can have this evaluation, these values here. So in this case, we can look for the LCM on the left hand side. Remember, this is a minus here, so we look for the LCM there. What are we going to have? LCM of those value is 4a squared. So if we get the LCM of that value, which is 4a squared, a will go into 4a squared 4a times, and 4a times negative c will give us negative 4ac, plus 4a squared will go into 4a squared 1 time. 1 times b squared will give us plus b squared. So but all of that is equals to x plus b on 2a, all that squared. So if we have these values, what can we do? We can take the square root on both sides to remove this square here on the left, because what is our aim? Our aim is to make x alone here, to get x equals to a certain quantity, right? Okay, so to make x to be alone, we are going to take the square root on this side, the left hand side, and the square root on the right hand side. So if we take the square root on both sides, we are going to have the square root there and the square root on the right hand side, and this square here can cancel that square root there. So we end up with a quantity of x plus b on 2 equals to the square root of minus 4ac plus b squared divided by 4a squared. But remember, a square root, the value of a square root must be a positive or a negative number. So the square root of any number has two answers, a positive number and a negative number. But in most cases, we always consider the positive number. So the square root of 4 is plus or negative 2. But in most cases, we just take the positive values. Okay, so let's continue with our question. So we have x plus b on 2a will be equals to square root, but which is positive or minus, as we said, square root of minus 4ac plus b squared, all of that divided by 4a squared divided by 4a squared, because the square root is distributive over division. So we can take the square root on the numerator and the square root on the denominator. Now if we evaluate the square root of 4a squared, the square root of 4 is 2, the square root of a squared is a. So all of this denominator will give us 2a, right? So we are going to have x plus b on 2a is equals to plus or minus square root of minus 4ac plus b squared divided by 2a. So we can bring b on 2a to the other side of the equation because we need x alone. Look at our equation here. X is equals to, so if we take b on 2a to the right hand side, x will be alone. So we'll have x equals to that. So when we do that, we are the value of b on 2a here is positive, so its value will go to, when going to the other side of the equation, will be negative. So in that case, we have x equals to negative b on 2a plus or minus b squared minus 4ac divided by 2a. Remember, nothing has changed here. We have just rearranged the equation from negative 4ac plus b squared to b squared minus 4ac. Nothing has changed, right? The negative sign here is for minus 4ac. So nothing has changed. It's just rearranging the equation to look beautiful. Okay, in that case now we are going to have the denominator here and the denominator here are the same. So we can just add and subtract the numerators. Or if you are not clear with what I'm talking about, you can look for the LCM here, which will be 2a, and 2a into 2a is 1 times minus b will be minus b, plus or minus 2a into 2a will be 1 times plus or minus square root of b squared minus 4ac will still give us all of that divided by 2a. So if the denominators are the same, we simply add or subtract the numerators. So in this case, the value of x will be minus b plus or minus square root of b squared minus 4ac. All of that means minus b plus or minus b squared minus 4ac, all of it divided by the common denominator, which is 2a. And you see, that is what we call our quadratic formula, which is the same as what we have here. So we have seen how to get a quadratic formula from a quadratic equation. So now let's use this quadratic formula to solve any quadratic equation. For example, this equation here, 3x squared minus 5x plus 2 equals to 0. What the only problem you will encounter here when using this quadratic formula is if you don't know what a is, what b is, and what c is. Because if you don't apply the right values of a, b, and c where they are supposed to be, then your answer will be wrong. So before you continue, it's recommended that you compare this quadratic equation to the general form of a quadratic equation, which is ax squared plus bx plus c equals to 0. From here, it clearly tells you that it has a value of 3, b has a value of minus 5, and c has a value of 2. So if we apply that to the quadratic formula, which is x equals to minus b plus or minus square root of b squared minus 4ac divided by a, we are going to have some values. So let's proceed and see how to substitute. So x will be equals to minus b. B is minus 5. So minus b will be minus 5 there, plus or minus square root of minus b is minus 5, no, square root of b squared is minus 5 squared minus 4, a is 3, c is 2. All of that divided by 2 into a is 3, so 2 into 3. So x will be equals to negative 5 is the same as 5. So x will be equals to 5 plus or minus. Minus 5 squared is minus 5 times minus 5, which is 25. And 4 times 3 is 12 times 2 is 24. So we'll have plus or minus square root of 25 minus 24. All of that divided by 2 times 3, which is 6. So in this case, we are going to have square root of 25 minus 24. 25 minus 24 is 1. So we have square root of 1. And square root of 1 is 1. So x is equals to 5 plus or minus square root of 1. All of that divided by 6. So in this case, we are going to look for square root of 1, and we know square root of 1 is 1. So we are going to have either the value of x will be x equals to 5 plus 1 over 6, which will give us 5 plus 1 is 6 over 6, and 6 over 6 is 1, which will give us a value of x equals to 1. Or when x has a negative value, x will be 5 minus 1 over 6, and 5 minus 1 is 4 over 6 will give us what? 2 over 3. So those are the values of x when we have the quadratic equation 3x squared minus 5x plus 2 equals to 0. So it's left with you now to apply this method on as many as possible quadratic equations you come across, so that this formula stay with you, because you will need it today, tomorrow, and at any time you are using quadratic equation, because it's easy to remember and easy to use if all the other methods prove abortive. So guys, that's how we use a quadratic equation formula to get the roots of a quadratic equation. This quadratic formula will only disturb or fail to work when the values of b squared minus 4ac are negative, because we can't have a negative square root of a number. So in that case, we say the quadratic equation has imaginary roots, or the roots are so complex that we can't get it using a quadratic equation. So that's how we handle questions like this. Stay with me and remain blessed. Don't forget to share this video. Bye bye.